Welcome to Brain Vision.
Hi, here in this given problem there is a pulley in the form of a solid cylinder. There is a string passing over that pulley and a bucket is attached with that string. Mass of the pulley this is given as m is equal to 3.45 kilogram and its radius, that is r, is equal to 0.420 meter. Distance fallen by the bucket after it is released vertical distance h, that is 5.25 meter. As it starts, it is released from rest, so vi will be taken as 0, initial speed will be taken as 0. Angular acceleration of the pulley as the string was unwinding, angular acceleration alpha, that is given as 3.98 radian per second square, and linear acceleration a, r alpha, which is given as, it is given to us as 1.67 meter per second square. Now in the first part of the problem we have to find moment of inertia of the pulley. Mi of the pulley is given by the relation being a solid cylinder. Its moment of inertia will be given by half m r square. So plugging in the known values here, this is half times of the mass of the pulley, which is 3.45 kilogram, into square of the radius, which is 0.420 meter, and it is calculated to be equal to 0.304 kilogram meter square. Answer for the first part of this given problem here. Then in the second part of the same problem, torque being exerted by the rope on the pulley. That torque will be found using the relation among the torque and moment of inertia and angular acceleration. Tau is equal to I alpha. For I, this is 0.304, which we have found in the first part. Alpha was given to us as 3.98. So this torque comes out to be equal to 1.21 Newton into meter. It becomes the second answer for this problem. Then in the third part, now we will use another expression for the torque. And that was tau is equal to, torque equals to product of the force applied at the rim, at the edge of the pulley, with the radius of the pulley, F into R. We get an expression for the force exerted by the rope on the pulley, and that will be tau by R. So this is 1.21 divided by 0.420. So finally this force comes out to be equal to 2.88 Newton, and this is the force, or we can say tension, exerted by the rope on the pulley. Answer for the third part of the problem. Then in the fourth part of the problem, this time we will use downward motion of the bucket, because we have to find the time in which the bucket will hit the ground. So for the downward motion of the bucket, h is equal to 5.25 meter, height to be covered, initial speed that was given as 0, linear acceleration that was given as 1.67 meter per second squared. So finally, using second equation of motion, h is equal to VIT plus half GT square, half AT square. So here it is, for h 5.25 is equal to 0 plus half into 1.67 into t square. So we get an expression for the time. T is equal to the square root of 2 times of 5.25 and divided by 1.67, and it comes out to be equal to 2.51 second. In this much time, the bucket will hit the ground. Answer for the fourth and the last part of this given problem here. Thank you.